Hello, my name is Joshua Grozen, and today I'm going to be showing you how to set equations for the circuit and plug them into a matrix. So the first thing that I notice when I'm looking at this circuit is that IS is directly connected to R3. So we can immediately determine the current going through that, or the voltage across it, by doing V3 is equal to IS times R3. And that's also going to be I3 is equal to IS. Simple. So the second thing that we do when looking at the circuit is we look for any loops that we can do. We can only do a loop here because it does not have any current sources. All the other possible loops do. So we can set this up by starting with our voltage gain from the negative 4V3 right there. So because we've already determined that V3 is just IS times R3, we can write that in right here, which will allow us to not have to do another row on the matrix, which is nice. And then we add that to R1, I1, because dropping, we add it up because we're determining which way we're going. We've already determined which way we're going. And then we can add that to R2, I2. And then because this is also going and giving it a voltage drop, we add it. Then we add that to R4, I4. Because again, it's dropping the voltage. So that's our loop. But we still need a little bit more information. So we set up the nodes. I'm going to do a node there and a node there in order to get us all the information that we need. So to calculate node A, we're just going to use Kirchhoff's current laws, which states that all current going into a node must go out. So that's pretty easy. We just do I1 plus I2 because both I1 and I2 are going in, minus I3 because it's going out. And then we write our second equation for node B, which is going to be I4 plus I3, and then minus I2, because I2 is the only one flowing out right there. And that gets us all the equations that we need to plug into a matrix. So for the first one, we can just start to set up the loop that we wrote. So that is going to be, actually, R1, and then R2, because they both add right there, and they both multiply by, we write in everything that multiplies by what's up here. And so for I3, because we have negative 4IS multiplying it, even though it's not in the loop, it still affects this right there. So to get the voltage off that, we do negative 4 I, or R3. And then for I4, we do R4. And because we have this VS in there, we write it right there. So for the next one, we can do this equation right here, which will get us 1, 1, negative 1, 0, because we're just adding that, and that. And this does not come into play at all. So what we do when we get that, because it has no voltage or current sources that really affect this node, we just put a 0 right there. And then for the next one, we can plug in our equation right here, actually, and get a 0, a 0, a 1, and a 0, because this guy is the only one that affects the voltage there, not the voltage, the current. And we plug in IS here because it's just directly on the same line. There's only one thing there. And then for our final node B, we plug in 0, negative 1, 1, and 1, which will get us a 0 right there too, because again, it doesn't have anything on its line that directly affects it. And then, yeah, that is our equation. When we actually solve this, so when we start to zero out values, what we will get is we will get all of the currents here. It's a lot of math to do, so plug it into a matrix calculator if you have it. And yeah, that's it.